Howdy! Welcome to Aspire Mountain Academy. I'm Professor Curtis, your instructor for this course in Introductory Statistics. In less than 10 minutes, this video provides practice in using StatCrunch to find probabilities for non-standard normal distributions. Let's get started. So to start with, let's look at an example problem in which we're looking at test scores for a recent exam in a history class. These scores are normally distributed with a mean score of 76.8 and a standard deviation of 2.67. The question we're asked to see here, what is the probability that a randomly selected student will score an A on the exam? We're going to assume that an A means you've got a score of 90 or more. So to do this, we can just put our values there into StatCrunch and calculate out our probabilities. So based on what you've seen in the previous mini lectures, I would ask you to pause the video here, get into StatCrunch, and see if you can find this on your own, and then come back in a moment and we'll look and see how you did. Okay, let's look and see how you did. So inside StatCrunch, you should have gotten the normal calculator, and notice the values that we put in. So we're going to put the mean and the standard deviation values here in our calculator. We want the probability, so here's our P for probability, that a randomly selected student will score 90 or more. So we have to put the greater than or equal to sign here. There's our random variable 90, and we press compute, and voila, there out comes our probability, which as you can see is a very, very small number. So in this particular class, it looks like getting that A is going to be really hard to do. Let's keep with the same problem of test scores, but this time we're going to ask a different question. What is the probability that a randomly selected student will score a B on the exam? So let's assume that a B is any score between 80 and 89.9. So once again, I want you to pause the video, go into StatCrunch, and see if you can calculate that probability. Then come back and we'll see how you did. Okay, so again, we want to go in and use StatCrunch to solve this. So in your normal calculator in StatCrunch, these are the numbers you should have. So if you didn't do anything with your calculator from the previous problem, you should still have your mean and standard deviation values here. But now what we're going to do is click this between option up here at the top, and that allows us to put two values in, so we get the value in between two values. And you can see here the graphical display of what it is you're trying to calculate between 80 and 89.9, which is somewhere way out here on the edge. That's the part that's shaded there in red. That's the area that we're actually calculating. And we can see when we hit compute, here comes the probability of getting a B out of the class. So much higher probability of getting a B than it is to get an A. Still though, 11.5%, I don't know if that's that. I don't like those odds. I'd rather have a much higher probability of getting a better grade. Note, again, you have to select that between option when you've got two bounds for your area underneath your density curve. Let's look at another problem. Same one that we're looking at before, but this time we want the probability that a randomly selected student will score a C or lower on the exam. So once again, go ahead and pause the video, get into StatCrunch, see if you can solve this problem, and then come back and we'll see how well you did. Okay, let's see how well you did. Once again, we're going to use StatCrunch to solve this. So here in your normal calculator, here's what you should have. Again, the mean and standard deviation values. We don't want the between options. You want to go back to the standard default selection where you're only putting in one random variable value. And we want less than 80%. So we're going to put the less than inequality sign here. There's our 80, which is the bound that you see here on the right for the area under the curve. Less than means we're looking at the area to the left. And when we hit compute, out comes the probability, 88.5%. Now, if you were to take the probabilities that were calculated for the previous two problems and add them together, you'd get the area that's on this side of your random variable, the area that's not shaded. So if I were to take this 88.5%, subtract it from 1, that gives me the area that's here on the other side. And that's the area that I get when I sum the probabilities from the previous two example problems. So everything works out to where everything adds up to 1 underneath your density curve. And depending upon which side you're going, StatCrunch makes it really easy to compute your probabilities no matter which side of the distribution you're looking at, or if you're looking for a portion of the distribution somewhere in between the tails. So there again is our answer, 88.5%. And that brings us to the end of this mini lecture. Thanks for watching. I hope you found it helpful. You can find more mini lectures for this and other courses at AspireMountainAcademy.com. So once again, thanks for watching, and I'll see you in the next video.